So we were able to satisfy those requirements there. Now the last requirement was if we were to have somebody cut a wire or there was a break in a connection on the 24 volt side, that the 120 volt side would simply activate. Okay, so let's try that. I should be able to pull this out. That breaks the connection going to my 24 volt side right from my power supply. And reset. Okay, so we were able to mimic that. I could have had a break anywhere in my, if I were to break any one of the connections going to my initiating devices, we would have been able to do the same thing. So I'm just going to try to mimic that as well. And every time I have to reset the button as well. I'm not going to go any further because that sounds a bit deafening. So we were able to complete our task where we needed to have a 24 volt circuit operating two 120 volt loads, the light and the alarm, using a 24 volt relay, and having that relay on operate a 24 volt circuit to control a 120 volt, two 120 volt loads. And that was our connections that we made. Just want to make sure that you understand, as a quick summary here, typically what we're trying to do is to send current to our coil on the 24 volt side to activate the coil, to pull in the armatures. And we have two different armatures, one of which the common is number 1, the other common is number 8. Each one of our armatures has a normally open position and a normally closed. So for example, between 1 and 3, that would be a normally open contact. When the coil is energized, my armature moves to the other position, my normally open becomes closed, and the normally closed becomes open. And the exact same thing happens on the other armature. We have to ensure that whenever we're dealing with two different voltages, that we never mix voltages on our contacts. I use two different armatures. Armature with common number 1 was being used for 24 volts for all of our labs here. And the armature with common number 8, I used it to work my 120 volt side. So make sure we never mix those terminations there. Okay, we can get relays that have a third armature if we need it, or a fourth armature, depending on what the scope is of the intent of work we're trying to create. There are multiple types that are on the market. We always have to ensure that we pick a relay coil that has the proper voltage rating, the proper current rating, and the proper number of armatures and normally open contacts and normally closed contacts. Also, the last thing I want to say is ensure that you have all of your schematic drawings accurately drawn. Make sure you have your line voltage for your 120 volt side on the left, your identified on the right, and also you have your low voltage. We have positive on the left, negative on the right. Make sure you show both your 24 and your 120 volt, your dual voltages that you are using here, and make sure all the connections are labeled for your relay, your coil. In this case, for this relay here, our coil was connected between 2 and 7. We have two sets of armature, like I said. Common is number 1, between 1 and 3 is normally open, between 1 and 4 normally closed. The other armature, the common, was number 8, between 8 and 6 was normally open, 8 and 5 was normally closed. The more information you have on your schematic drawing showing terminations of all this, then when you finish writing your schematic drawing, you can go with that schematic to real world physical connection, and you can verify each wire is going to the proper terminal and connection. That's it for our Relays and Controls lab. If you have any other questions, ask your instructor. Thank you.